Now that we've created the tables, we're going to take a look at how to create queries and pull data out of various tables. Let's look at a few examples of queries. Here's a student's query that lists every single assignment that various students took. So it pulls data out of 4 different tables. It pulls it out of the students table, getting the first and last name of the student. It pulls it out of the course table, getting the department that the course is offered in. Pulls out of the faculty table to get the last name of the faculty member who teaches the course. It pulls out of the assignment table to get the type, points received, and points possible of each of the assignments that are listed. So I will now demonstrate how to make a query that pulls all this information out of the various tables. First thing we do is go up to the Create tab, and then we'll click Query Wizard. This will allow us to create a few different types. Today I'm going to demonstrate the Simple Query Wizard and the Crosstab Query Wizard. The simple one is pretty easy to use. You go to you select the various tables that you want up here, and then you just insert the fields that you want to pull from. So in this case, let's pull from the first name and last name from the students table. We'll go into the courses table and get the department that the course is offered in. We'll pull from the faculty table and put the last name of the faculty member, and then we'll go in the assignments table and pull out the type of assignment, the points possible, and the points received. So we've gone through 4 different tables and selected different fields. We selected the first name and last name of the students, the department, the last name of the faculty, the type, the points possible, and the points received. You'll notice that since both students and faculty have a field name last name, they differentiate by putting the table that this field comes from, and then a dot, and then the field name. So here we have 7 fields that are pulled from 4 different tables, and they'll make what looks like one table. I'm going to demonstrate the detail option this time, and then we'll do the summary next time. So there are 2 types of the simple queries. And let's open it to view. So these are the same exact queries, except this one has the points possible listed first, and then the points received, and this one has the points received, and then the points possible. So let's go ahead and close this. So this query just looks like another table, but really it's dependent on all of these other tables. If we run the query again, after updating information about these, it'll show up in the query. So in the students table, we would just have to update Tony Stark's name to Anthony Stark. And after we update that, when we run the query, you can see that the first name is updated in every single assignment. This is one of the biggest benefits of databases. You can separate information about each entity. So here we changed the name of Tony Stark to Anthony Stark, and that updated in every single place that we pulled that information from. This helps us keep the data consistent across all of the database and allows us to update one place, which will propagate out and update all the other places that information is referenced. Now let's go ahead and make another simple query, but we'll make it a sum query. This is the query that we'll be designing. It takes the number of points possible from each of the assignments and it averages them, and then it takes the points received and averages those. So Charles Xavier took one assignment and got 100 out of 100. Clark Kent took several assignments in PE and got a 24.5 out of the average 32.5. So if he would have gotten 100%, this number would be 32.5. but since it's not, it's obvious that he missed points somewhere along the way. In philosophy, there are 10 points possible, and he averaged to get 7.5 out of those 10. So maybe he was offered 3 different assignments worth 10 points, and on one he got a 6, on another he got a 7, and on the third he got an 8. Well, in that course he got a 75% out of 10, so 7.5. Let me demonstrate how to make this query. So if you go back into the query wizard, this time we're still going to do a simple query. We're going to go back to the students table, and we're going to do the first name and last name of the student. We'll do the course, department. Actually, and instead of doing the department like in here, we'll just do an average of all the points that they have received. So if we go to the assignments table, we'll put in points received and points possible. And we'll click summary here rather than detail. You can see in this little box that it demonstrates how summary works. You can either sum all of the numbers, or you can take an average of the numbers. The summing of the numbers wouldn't really show us much, since we know that different classes offer different points. But if we take the average, we can know how the students have done in general. So then we'll click summary options, and we'll average the points received and the points possible for each of these students. So this time, because we didn't select department as we did here, it's going to take their scores in several different classes and average them together as well. So here we see, of all the classes, Charles Xavier got 100 out of 100. Of all the classes, Kurt Wagner got 9 out of 10 on average. Clark Kent got 22.1 out of 28. So that's roughly a B, a low B. So Clark Kent took the average of all these 4 classes, rather than in this query where it divided it up by department. So if you leave out a field like we did, it will combine several of those into one. So this score right here is out of all 4 of Clark Kent's classes. Now I'm going to demonstrate the Crosstab query in another database. This probably looks familiar to you because you saw something similar on the last unguided exercise for Excel. These are all the different sales of each of the products for a company. There are several types of beverages, several types of condiments, and it lists out how much each of these made for each quarter. If you're reading data like this, it doesn't really help you. Here's a crosstab query. It has taken the quarters, which are in the quarter field, and has lined them up in the row to make the data more understandable. Crosstab queries allow us to pick one field to make the row headings. So each of these describe the row that they're in, and another field to make the column headings. So quarter 1 and quarter 2 are 2 different column headings. And then to pick a number that has each of these. So this is another way to see all this information, but it makes it easier to find in the crosstab. So if we want to see quarter 2 for Shogi Chocolate, we can see that in quarter 2 it sold 5,268. Now let me show you how to make this query. We'll do a crosstab query, and we'll go from the sales table, For the columns, for this time, we previously did the product. Let's go ahead and do the category. So the category will be each of the row headings, and it'll be the first column on the table. Now we get to pick the column headings, and again, it makes probably the most sense to do it by quarter. And then for sales, we'll do a sum of all sales in that quarter. And let's look at that. So here you'll notice there are a lot less because each of these products falls within a certain category. So there are only 8 categories. And you can see which of the categories did the best in various quarters by sorting by that quarter. So here beverages did the best, but here dairy products did the best, and overall dairy products did the best. So this is one way queries are a good way to sort data and to combine data from various tables to organize it by making one of the entries for the fields into column headings, to link various information across the separate tables into one new table. This is just a view of all the information in other tables. As we saw when I updated Tony Stark's name in the other table, it automatically changed it in this query. But yeah, this allows us to view data from various tables in one place. Next, we'll look at forms, which allow us to insert new data in an easier way than going through and adding records in this way.